Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
In the winter of 2019, the American Midwest and Northeast turned into a real-life disaster movie. I'm talking about that time when temperatures dropped to negative 63 degrees Fahrenheit, There were massive flight cancellations and power outages, dozens of injured people, and shut down schools and offices. Simply going outside became highly risky. And if you're looking for someone to blame for all this, I've got two words for you: polar vortex. That's not some scary storm, but a huge mass of cold air that's normally spinning counterclockwise around the poles. When it's summer up in the northern hemisphere, the vortex stays further north, and in the winter, it heads south a bit. The term polar vortex has been around since the late 1940s. It shows up every winter and calls it quits in the spring. But for about the last 20 years, this polar vortex has been acting weird in the middle of winter. It looks like it either splits or becomes displaced once every other year. At the bottom of this vortex is what they call the polar front, or the polar jet stream. This jet stream moves from west to east, which is why places like the northeastern part of North America get hammered by that chilly polar vortex weather. Ooh. These jet streams zip along because of differences in temperature and the Earth's spin. When there's a big gap in temperatures, the winds really pick up speed. In spots like the equator, where the sun's rays are more intense, the air heats up and starts to rise. And as it goes up, it leaves behind a sort of empty space, taking in air from all around, kind of like a huge vacuum cleaner. But over at the poles, where it's way chillier, the air shrinks and sinks, forming areas of high pressure. It's like a bunch of air molecules trying to spread out, like a group of school kids on a big field. So you've got these two forces at play: warm air rising and cold air sinking. Air wants to zoom from the poles down to the equator with this setup. The jet streams tend to hang out where airplanes fly, about 30,000 feet in the air. Pilots often use them to zoom across the sky faster and save some fuel. But these jet streams aren't always the good guys, as they can bring all sorts of weather changes, like cold snaps and heat waves. When the polar jet stream is strong and cruising at about the same level as the vortex, it kind of locks in that cold Arctic air within the Arctic Circle. Every now and then, the jet stream takes a chill pill and starts moving around the planet in a wavy pattern called Arctic oscillations. This creates peaks and troughs that allow warmer air from down south to head north, and the chilly Arctic air to take a trip south. In the northern hemisphere, there are two polar vortexes, one in the lower atmosphere known as the troposphere, and another higher up in the stratosphere. The stratospheric vortex forms as cold, dense air sinks and twirls near the North Pole. The mightier the vortex, the quicker it spins, keeping cold air locked over the high latitudes. When someone or something messes with the polar vortex, it goes haywire. Picture a spinning top. Give the table a shake and it'll start wobbling. When the polar vortex loses strength, it can't corral the cold air anymore. So, blasts of icy Arctic air surge southward over North America. The polar vortex isn't a fixed object, but more like a living being. It gets stirred up by ripples on Earth's surface, triggered by stuff like air flowing over mountains or across land and sea, all warming up differently. If our planet were as smooth as glass, with oceans wrapping all around, the polar vortex would just chill out, never breaking up. But every time a wave smacks into it, it gives the vortex a push. Sometimes, one of these waves packs enough punch to shove the vortex off the pole or even spin it in reverse. And when that happens, the temperature in the polar stratosphere can skyrocket by a whopping 50 degrees in just a week. The Arctic's polar vortex started spinning in the opposite direction in March 2024 and got scientists worried. It's one of the 6 strongest flips since the 70s. This time around, it hasn't caused any chaos. Sometimes the waves of air affecting the vortex get strong enough to split it into 2 parts, kind of like how a cell divides. They're called daughter vortices, and they even add more chaos to the mix. When the vortex splits, one chunk usually heads over Siberia, while the other cruises over North America. Once that split goes down, the jet stream in the troposphere above the Atlantic decides to take a southern vacation. That jet stream usually acts like a bouncer, keeping the chilly Arctic air up near the pole. But when it heads south, that Arctic air gets a green light to crash the party in places like the East Coast, the Midwest, and even Western Europe. The storms that usually ride along with the jet stream follow along and head south too. They take their time to get organized and catch up with the new path of the jet. So, instead of hitting up Canada like they usually do, they swing by New York and Chicago for a change of scenery. Scientists still don't know why the polar vortex doesn't mess with the U.S. Pacific coast. It might have something to do with where the jet streams hang out in each basin. Over in the Atlantic, the jet stream kicks it at higher latitudes, while in the Pacific, it's chilling closer to the equator. It might also have to do with the landscape. In the Atlantic, the air has zipped over the Rocky Mountains, stirring up waves off tall peaks that mess with the jet stream. But in the Pacific, the jet stream is away from any big mountains that could cause trouble. The recent reversal of the polar vortex is unlikely to make the temperatures drop extremely, but scientists aren't sure what's going to happen to the polar jet stream in the future. They're concerned that the chilly polar air might make more trips down to the mid-latitudes and bring along more chilly spells in the long run. So it's better to be prepared. When the news tells you there's a huge winter storm coming and power outages are highly likely, fill your bathtub with water. If you have an electric water pump, it won't work and you'll run out of water soon. Gas stations also run on electricity, so fill your car tank before the storm hits to have some emergency gas. When the storm arrives and you're locked in, put on several layers of warm clothes, thermal wear, a warm shirt, a sweater, and insulated pants and woolen socks. Don't forget mittens so the heat doesn't escape through your hands. Hang dark blankets on your windows to draw in heat. Make sure your doors and windows are closed well, and put some towels under them to prevent drafts. Your basement is probably more insulated by the ground, so it could be a good place to spend the night. To warm up the cold winter bed in your home, fill a bottle with hot water and place it in your core region under the cover. The water will heat up your vital fluids traveling through your body, reaching all the extremities and warming you up in no time. You can also wrap your pajamas around the bottle before putting them on for an extra effect. When the power comes back on, check all your appliances and electronics before turning on the main power switch. They must be unplugged to avoid power surge damage. As you turn the water supply back on, keep the taps on the lowest level of your house closed to let the air out from the upper taps. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So the thing is, a massive volcanic eruption today could be even more devastating than the year without a summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sundhnúkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the U.S. was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter. although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
Ah, a purple sunset. You must have seen one of those at least once in your life. Normally, it's nothing ominous and has to do with the way light travels. The light that the sun produces is white. When it goes through a prism, you see light waves of different colors, from red and orange to blue, green, and indigo. Light normally travels in a straight line if there's no obstacle in its way. The shorter light waves, including blues and purples, are scattered easier when they meet with those obstacles, like molecules and aerosols in the atmosphere. Because the sun is low on the horizon at sunset and sunrise, its light has to pass through more molecules that scatter the violet and blue light. The colors that your eyes pick up, then, are yellow, orange, and red. But with the right conditions, you can see the gorgeous purple sky. Sometimes purple sky appears for much scarier reasons. It can be caused by hurricanes, wildfires, or dust storms. The concentration of vapor in the air increases, and the light scatters more than usual. Dust, a setting sun, and low cloud cover all contribute to this natural show, too. The sky turns orange and red at dusk if there's still enough light. Then it gives off pink hues, which mix up with a dark blue sky above. Now, do you remember what happens when you mix pink and blue? You get the color purple. Not every hurricane makes the sky turn purple, and trying to predict if it's going to happen is like trying to forecast a rainbow. Still, people reported several major hurricanes made the skies turn purple. Now, green skies might look just as spectacular as purple ones, but they actually also scream danger. They're usually there to tell you a thunderstorm, hailstorm, or a tornado is somewhere nearby. The unique color is a result of yellow sun rays getting mixed with the blue light coming from storm clouds. So you're enjoying a nice day by the ocean with a fresh breeze in your hair, when suddenly you notice the water starts retreating from the beach at a huge speed. This is a sign for you to start running as fast and far away from the beach as you can. This most likely means that a tsunami is on the way. A quick reaction maximizes your chances of survival. Now, if you notice the sea level is rising, but it doesn't seem too extreme, it could be another sign of an approaching tsunami. It happens in 40% of cases, and the incoming water is the first tsunami wave. The next one, way larger and more dangerous, usually follows in about 10 minutes. Another thing about tsunamis is that they like to arrive with some loud sounds. People describe them as thunder, the sound of a locomotive, a helicopter, or just a loud boom. Do you see a channel of choppy water on the beach? It's in your best interest to stay away from the water. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange break in the waves, or an area with a different color than the rest of the water. Random bits of seaweed going in all directions is another rip current warning sign. If you happen to find yourself caught in a rip current, try to stay afloat, but don't try to go against the current. You'll only waste precious energy. Scream for help and try to float your way along the beach. Once you break out of the current, swim diagonally to the shore. The next time you spot conically shaped clouds in the sky, remember it's a good time to start looking for some shelter. If it just stays like that, a severe storm is on the way. But if a cloud of that shape starts spinning around, it means it's about to transform into a tornado. If you have bees nearby, they can save you from big trouble one day. These hard-working little guys get more active than usual when they feel like a storm is on the way. They speed up to collect more nectar before it hits them, and once they're done with it, they'll always come back to the hive 10 to 15 minutes before heavy rain, even when there are no obvious signs of it coming. Their secret is super sensitive hairs on the back that can pick up electrostatic buildups from storm clouds. For centuries, people have noticed that animals act weirdly a couple of days before big seismic events. Dogs can't stop barking, cows halt their milk, and toads, rats, and snakes leave their homes. It looks like animals can feel smaller initial shock waves that humans don't even notice. Scientists have tried to find some legit explanation for it and run endless tests and experiments. But so far, they're still on their way to explaining this mystery. Can you smell ozone in the air? When a thunderstorm is on the way, it's the most distinct and pungent smell you can pick up. An electrical charge of lightning sets it free from higher altitudes. The other, more pleasant smell of rain is petrichor. Rainwater wakes up molecules on plants, trees, concrete, and asphalt. Their aroma spreads all over the place. You can even feel that smell in your own mouth. All those positive ions in the air that a lightning bolt sets free gets mixed with ozone and your saliva, and that's how you get that bitter metallic taste. When lightning is about to strike, you might hear bizarre crackling, buzzing, or vibrating sounds coming from metal objects nearby. Your palms may begin to sweat, and then you can feel your hair stand on end. That's a clear call for action, and that action is to run for your life. Positive charges are going through your body trying to reach toward the negatively charged part of the storm. Trust me, you don't want these charges to meet. If you see no shelter that you can reach fast, try to make yourself smaller than the objects around you. Drop down your umbrella and stay away from wire fences, metal pipes, rails, and other metallic objects. And don't lie flat on the ground, it's likely wet, which means it's a great conductor of electricity. If you suddenly notice crevices in the asphalt next to your house, it could be a sinkhole warning sign. Inspect your house on the inside. Does that door begin to jam? Or maybe there's a gap where the walls meet the ceiling. Uneven kitchen cabinets and drawers, slanted floors, stairs that begin to slope, water leaking after every rain, and displaced moldings are all signs that a sinkhole is about to open. To find out if it's definitely a sinkhole and how dangerous it is, you gotta consult with an engineering company. If you find a sinkhole that's already there, you gotta stay away from the sinkhole area. Fence or rope it off to make it less dangerous for others. You'll need professional help to fix it. Some volcanoes scream when they're about to erupt. Small earthquakes, which often happen before, produce a hum. It's mostly non-audible to human ears, but sometimes it reaches a frequency that lets you hear it as a strange rumbling or hissing sound coming from the ground. This noise is known as a harmonic tremor. With some volcanoes, it's the sound of magma bubbles vibrating when they're going through crevices in the crust of the Earth. But it's not always like this. If scientists manage to understand what exactly causes these volcanic screams, they could create a limited early warning system for volcanic eruptions. If you're out in the wild, pay attention to the water in creeks, streams, and rivers. If its level is quickly falling, even if it's raining, this might be a sign of a nearing landslide. And if you hear a faint rumbling noise or unusual sounds, like boulders knocking together, it could mean debris is on its way to you. It's a sign to head to safety immediately, like right now.
Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures: mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark. Streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, 2 thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather. Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's gonna be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem. No land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Ediacaran fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age. Earth isn't a perfect ball, we know that. But the real mystery is miles beneath our feet. Way down below the crust, the planet has been cooling down for billions of years, just not evenly. The Pacific side loses heat faster, while the African side slows that loss by trapping it longer. That difference is why Earth stays restless, with earthquakes tearing the ground apart and volcanic fire breaking through the surface. Think of Earth like a massive engine that's been shut off. The outside cools first, but deep inside, heat lingers. That internal heat is leftover energy from when the planet formed, and it's been slowly trying to escape ever since. For a long time, scientists assumed Earth lost heat evenly in all directions, hot in the middle, slowly cooling everywhere else. But when a team at the University of Oslo ran simulations that rewound the planet 400 million years and tracked where the heat actually escaped, they saw something very different. The cooling wasn't symmetrical at all. One side of the planet is doing it faster than the other. The difference is striking. The Pacific Hemisphere, the side dominated by the world's largest and deepest ocean, has cooled by about 50 degrees Kelvin, which is roughly 90 degrees Fahrenheit difference, compared to the Africa-Eurasia side. The reason is basically insulation. Africa and Eurasia are on a layered ancient continental crust. The Pacific side is the opposite. It's mostly ocean, resting on a much thinner crust where warmth escapes easily. Plus, the cold seawater on top pulls that heat out non-stop. Because the Pacific side is cooling so fast, the rock deep underground is getting heavy and sinking back toward the core. It's like a giant slow-motion conveyor belt that drags the Earth's crust down with it. Heavy materials sink. As it sinks, it pulls on the edges of tectonic plates, creating stress, trenches, earthquakes, and chains of volcanoes. Most of Earth's earthquakes and volcanoes happen in a giant loop called the Ring of Fire. This is where the ocean floor gets cold, heavy, and sinks deep into the planet. All that sinking rock travels thousands of miles down until it slams into a massive continent-sized structure sitting right near Earth's core. Scientists call this a blob because the heavy ocean floor is constantly falling on top of it. The Pacific blob is squashed flat and pinned down, sitting heavy and locked in place. But the other half of the world is doing the exact opposite. Under Africa, there aren't many sinking plates to act as a weight. Without that pressure holding it down, the African blob is free to grow tall and light. It pushes upward, lifting the ground from below and reshaping the entire continent. In fact, that rising bubble is already starting to tear the surface apart. In East Africa, a massive crack known as the Great Rift Valley is slowly opening up as the ground is pushed from below. Eventually, the pressure will become so high that Africa will literally split in two, allowing a brand new ocean to rush into the gap. There's a cool theory that suggests these blobs might actually be the remains of an ancient planet named Theia. Some researchers believe that Theia crashed into Earth billions of years ago, and while part of it broke off to form the moon, some heavy chunks might have sunk deep inside our planet. So, the reason our interior is so lopsided might be because we literally have pieces of a different world buried inside our own. But that's just a wild theory. Whatever their origin, the blobs matter because they help split the planet into two different behaviors. On the Pacific side, cold slabs keep sinking down and piling up. On the opposite side, heat builds up deep and pushes upward over time. One half is dominated by downward motion, the other by upward motion. And this imbalance doesn't stop at the mantle. It shows up at the very center of the planet because Earth's inner core is still growing. Liquid iron around it gradually turns solid and attaches to the core. This process doesn't progress at the same rate everywhere. One side of the inner core builds up faster than the other. This might sound like it should throw the planet off balance, but it doesn't. Earth's interior isn't rigid like a solid metal ball. Over time, stuff inside can gradually move around. Gravity pulls everything toward the center, helping everything get a bit smoother and keeping the core pretty round. But pretty round doesn't mean perfect. If you want a real example of how uneven Earth is on the inside, look at the Indian Ocean. Where there's more mass underground, gravity pulls a little harder. Where there's less mass, it pulls less. In the middle of the Indian Ocean, there's a huge anomaly called the Indian Ocean Gravity Hole. In that spot, Earth's pull is weaker than normal, so weak that it can't hold the ocean surface up at the usual level. The water actually dips downward. You wouldn't notice it sailing through, but you'd technically be sitting about 300 feet lower than the rest of the world's oceans. It's an invisible valley in the sea caused entirely by missing mass deep inside the planet. However, Earth isn't the only world hiding a messy interior behind a smooth surface. Even the moon is like this. Over billions of years, Earth's gravity slowed the moon's rotation until it locked into place, keeping one face permanently pointed toward Earth. That's what we know as the near side and the far side. This mattered early in the moon's history. The near side always faced Earth, while the far side always faced deep space. That long-term setup affected how heat was stored and released inside the moon. When NASA mapped the moon's gravity using two spacecraft called GRAIL, they measured something called the love number. It's a value that tells scientists how much a planet or moon flexes under gravity. The moon's love number turned out higher than expected, which meant its interior was softer than it should be. When scientists looked closer at the gravity data, they found that most of this flexibility came from the side facing Earth. The moon's near side is softer and warmer deep down, while the far side is cooler and more rigid. Measurements suggest the near side mantle is significantly hotter and more volcanic. That difference shows on the outside. Because the near side was so hot and soft, ancient lava could easily punch through the crust and flood the surface. That created those big dark patches we see at night. On the other hand, the far side stayed colder and stiffer, so the lava never flowed the same way. Back on Earth, the Pacific has another quirk worth mentioning. Our planet isn't just spinning in place. It orbits the sun at over 66,000 miles per hour, and the entire solar system is moving through the galaxy like a car driving through a swarm of bugs. Over long periods of time, objects drifting in from deep space are more likely to hit the side of Earth that's moving forward. And because the Pacific Ocean covers such a huge stretch of that side of the planet, it naturally ends up catching more impacts than smaller oceans or continents. This creates a strange coincidence. The same hemisphere that is leaking the most heat from within is also the world's biggest graveyard for things arriving from the outside. Because it is so vast and lonely, Space agencies even use its most remote coordinates as a spacecraft cemetery at a spot called Point Nemo. We deliberately aim satellites and massive space stations like Mir to crash right there. So, the Pacific ends up taking the hits from two directions, by accident from the universe and on purpose from us. Earth is restless, continents drift, oceans open and close. In a few 100 million years, the map will look completely different. The Pacific is actually shrinking right now. Eventually, the Americas might crash into Asia, and a new ocean will have to take over the job of being the planet's main radiator and its front bumper. But for now, we should probably be thankful for that massive, chilly, unlucky ocean. A sinkhole suddenly appeared in northern Siberia. This 115-foot deep hole popped up after some weird explosion that threw dirt and rocks almost 395 feet away. Since then, 2 more mystery holes have shown up in the area. People first thought it might be connected to digging for fossil fuels, since it's not far from the biggest gas field. But the search team's radar scan suggested it was probably a natural thing. The first research trip wasn't too successful because scientists couldn't get inside and take samples until the hole's sides and the water at the bottom froze. Scientists have been wondering about what caused these holes, and the ideas varied from space rocks hitting the ground to rising temperatures on Earth. One researcher suggested that the eruption had occurred due to the accumulation of pressure. A temperature decrease is often accompanied by alterations in the volume of specific chambers. These chambers contain methane. Such craters are specific to the Arctic region. Few other areas share these particular features. They all have table-like ground ice situated close to the surface, continuous permafrost saturated with methane, and unfrozen ground. Speaking of gases, a geologist suggested that the sinkhole might have been caused by gas hydrates. These gas hydrates are also thought to be responsible for mysterious happenings in the Bermuda Triangle. The Yamal Peninsula, similar to the Bermuda Triangle, has been a place known for unexplained events. Here, residents even claim to have seen the abominable snowman. Sinkholes can pop up out of nowhere. Some are massive enough to gobble up whole buildings. They happen when rock under the ground, like limestone, starts getting dissolved by the water it contains. As the rock melts away, these big holes, or caverns, start forming. When these caverns become too much for the land above to handle, bam! The surface caves in. Ice is melting like crazy. The Arctic is warming up way faster than the rest of the world, so ice sheets and glaciers are shrinking. As these chunks of ice melt, they pour fresh water into the oceans, raising sea levels and making Earth's crust sink. During the last ice age, those massive ice sheets pushed down on Earth's crust, making it bend and sink. When the ice started melting, the crust began to bounce back. But now, the ice is melting too fast for the crust to keep up. This sinking situation creates a dangerous loop. As land goes down, more seawater creeps in, causing more erosion and flooding. What about other parts of the world, such as China? It hosts the deepest and largest sinkhole on the planet. This sinkhole is 2,165 feet deep and holds a crazy amount of space, 130 million cubic meters to be exact. They call it the Heavenly Pit, and it's not just big. It has its own mini ecosystem. 1,285 different plant and animal species can be found there. There's an ancient forest and a thick jungle of plants in there. This formation is a double-nested sinkhole with 2 craters connected by a sloping edge. When it rains, a waterfall shows up at the mouth. It feeds an underground river and cave network. When you look down from space, you'll see these deep, dark marks on the green landscape, like a footprint. Some suggested that these formations could have been left by a meteorite smashing into Earth. Others said it had taken about 128,000 years for water to carve them out. It could have snuck into underground rivers and worn away the limestone rock. It turns out, locals have known about this place for ages, but the rest of the world only caught wind of it in 1994. British explorers tried to map out its underground cave system, but it's like a maze down there. After 5 tries in a 10-year span, the team couldn't handle the rushing river and had to throw in the towel. So, this deep, mysterious underworld remains one of China's biggest geological puzzles. The next one is Crveno Jezero in Croatia. This is a huge, mysterious pit. It's not like a regular lake. It's basically a giant hole that formed when the ground collapsed into what was once a massive cave. The walls are super steep and have this reddish tint because of iron in the soil, which makes it look pretty wild. Inside, there's a deep blue lake that's incredibly clear, but also super cold. What's really cool is that it houses a unique species of fish that's only found there. Plus, the water level goes up and down because of an underground stream. It's a bit of an adventure to explore the lake because it's surrounded by sheer cliffs that can drop rocks without warning. Let's shift our gaze to Venezuela's Cima Humboldt. This is a colossal sinkhole hanging out in a flat-topped mountain. This beast of a hole plunges down 1,030 feet. You can find an entire forest at its base. It's home to many plants and animals that only live there, like a unique frog called Stephania rhei. In 1974, people went on an exciting trip there for the first time, and they had to cut down trees so that helicopters could come and pick them up, kind of like something you'd see in an Indiana Jones movie. The second largest blue hole on the planet, known as Tamya, which translates to deep water in Mayan, is in Mexico, and that's where we're going. This underwater marvel was uncovered off the shores of Mexico's Yucatan Peninsula in 2021. But the deets about this sinkhole have just surfaced recently. It's 900 feet deep, with the sides so steep they're almost 80 degrees. The entrance to this cavern is about 15 feet below sea level. Blue holes like Tamya are these natural wonders formed during the ice ages. When the sea level was way lower, rain and other natural elements eroded limestone, creating these deep, vertical shafts. Then, as the oceans filled back up, these holes got submerged, turning into the mysterious blue holes we see today. They're called blue because the deep parts are darker than the shallower waters around them, making them look striking from above. Despite being low in oxygen, which usually makes it tough for sea life to thrive, blue holes are bustling with unique forms of life, especially bacteria. They're also gold mines for scientists because they can preserve ancient fossils in conditions you wouldn't normally find elsewhere. The team that discovered Tamya used scuba gear, sonar equipment, and water sample testing to map out the blue hole and study its water chemistry. They found that it was not just deep, but also massive, covering a surface area of 147,357 square feet at its widest point. This discovery was made partly thanks to local fishers who had been whispering about its existence. Now, scientists are diving deep into its secrets, hoping to learn more about the unique ecosystems that blue holes can host, and how they might give us clues about handling climate change and preserving marine life. Another spot is Dean's Blue Hole. This one is just off Long Island in the Bahamas. This underwater wonder goes deep, reaching 663 feet. The massive blue hole is surrounded by rocks, a lagoon, and a pristine white beach. Dean's Blue Hole isn't just a pretty sight, it's a hotspot for freediving enthusiasts. People come from all over the world to take the plunge into its crystal clear depths. There are multiple passages branching off from the main blue hole, leading into intricate cave systems and mysterious underwater rooms. It stands out also because it's the second deepest blue hole in the world, falling just behind the Dragon Hole in the South China Sea. This place is a big deal in the scuba diving world, especially since a swimmer set a world record here by diving 331 feet deep on a single breath. without any fins.
Hey, do you believe in folklore telltale signs that can help predict the weather? Actually, many of them even have a scientific backup. So let's dive in. You've probably heard this one at least once. Red sky at night, sailor's delight. Red sky in the morning, sailor's warning. Oh, you haven't? Then you might have heard a variation with the word shepherd instead of sailor. This weather lore was even commemorated by William Shakespeare, I call him Bill, back in 1593. He wrote a poem, Venus and Adonis, and there is a description of the red sky lore. Turns out Bill was right, and this one can be explained. The red sky appears when dust and small particles are trapped in the atmosphere by high pressure. When sunlight passes through the Earth's atmosphere, it splits into different colors of the spectrum and creates colorful skies. If there's a high-pressure system, it can trap dust and vapor in the atmosphere, causing blue light to scatter and leaving only red. So it can indicate that the weather will be clear and calm the next day, whereas a red sky in the morning can indicate a storm is on the way. How about another one with sailors? Rainbow in the morning gives you fair warning. Rainbow at night is a sailor's delight. Now this suggests that if you see a rainbow in the morning, it means that rain is on the way. However, if you see a rainbow at night, it means that the weather will be calm and clear the following day. And the pot of gold at the end of the rainbow is still a myth. Next one. They say no weather is ill if the wind be still. This one's pretty logical too. Calm weather conditions show us that the pressure is high in this area. Highs are regions of descending air, and they prevent bad weather phenomena, such as clouds and precipitation, from forming. But there's more to that. Actually, calm conditions may be a true sign that bad weather's on the way. We often call it the calm before the storm. Have you ever seen this halo around the sun or moon? Well, it's another telltale weather sign. Next time you spot such a halo, make sure to grab an umbrella before you leave the house. This phenomenon occurs because of refraction. The sun and moon provide light, although in different ways, and this light gets refracted by ice crystals at high altitudes. When you see a halo, it means that the moisture up there is going down. Also, these halos may evolve into another beautiful phenomenon, milk sky. The milk sky is still clear, but the typical blue shade is sort of washed away and appears a bit faded or milky. Today, we can just check the weather forecast on our iPhones. But centuries ago, people needed to have some alternatives to be able to predict the weather. The very first weather forecasts appeared around 650 BCE. Back then, the Babylonians would predict weather using cloud patterns. Ooh, that's a fluffy one. Uh-oh, there's a dark one. We should go inside. People had to wait for quite a lot of centuries for mass weather forecasting. The first prototype of what we have today appeared in 1835, and it was thanks to the invention of the electric telegraph. By the way, back in the olden days, animals contributed a lot to weather forecasting. Some traditions are preserved up to today. For instance, Groundhog Day. Long story short, if the groundhog gets out of its den on the 2nd of February in Punxsutawney, Pennsylvania, and sees its shadow, it will go back into the den, and the winter will last for 6 more weeks. On the contrary, if the groundhog does not see its shadow and doesn't get scared, spring will arrive soon this year. There's no actual scientific backup to this tradition, but surprisingly, in most cases, the groundhog predictions come true. Well, in the US, people get predictions from groundhogs. In Croatia and Serbia, people use bears to see if spring's on the way. On the 15th of February, they watch a bear awaken from winter dormancy. It's all about the shadow again. If the bear gets confused when he sees his shadow, it will go back to its den and sleep for 40 more days, thus prolonging the winter. But if it's cloudy on this day, it's a true sign that spring is coming. As to the poor schmuck who has chosen to wake the bear up, I think I'd pass on that honor. Unlike groundhogs and bears, seagulls can help predict bad weather all year round. They say, "Seagull, seagull, sit on the sand. It's never good weather when you're on the land." These birdies tend to sleep on the water, so if they sense turbulent wind, they prefer not to struggle with it but avoid it. Therefore, they just land on the beach and wait. Smart! Rain before 7, clear by 11. pretty common, but only partly true. The occurrence of late night and early morning rains may be due to the passing of a weather front. Still, it's not 100% correct to assume that morning rain is a sign that the afternoon will be dry. In some cases, a rainstorm that develops in the late afternoon may last up until the night, causing early morning rain. Now, cows could make good weather forecast reporters too. A cow with its tail to the west makes the weather best. A cow with its tail to the east makes the weather least. Thing is, they don't really enjoy it when the wind is blowing right in their faces, so they prefer to stand with their backs to the wind. Winds blowing from the west usually bring good weather, and those blowing from the east, on the contrary, are likely to provide unsettled weather. Voila! I told you, cows are cool. So, should you ever be in a pasture with cows, you will know what weather it will be in the next few hours, even if there's no coverage and you can't use your phone. Now, in case there are no cows, bears, or any other animals that are sensitive to the weather, you can use onions. Yep, you heard that right. Even onions can predict the weather, and these guys actually predict long-term conditions. Here's a nice rhyme. Onion skins very thin, mild weather coming in. Onion skins thick and tough, coming winter cold and rough. Well, seems there's no prediction connected to French fried onion rings though. If you want to hear a scientific explanation for this, sorry, there won't be any. In fact, scientists say such rhymes have stood the test of time for one reason only, and it's our human selective memory. We tend to remember things we've predicted correctly, and if not, we just forget them. Oaks and maples can be helpful, though, due to their ability to curl leaves when the humidity is very high and the wind's blowing strongly. So, when leaves turn their back, 'tis a sign it's going to rain, turns out to be quite a true saying. There's even a rhyme for it. When the leaves show their undersides, be very sure that rain betides. I know, betides, it's kind of a forced rhyme, but it is a word, it means happens. Okay, time to move on, let's not beat a dead horse, which, by the way, is not a weather predictor. So hey, did you know that you can even use your friends to predict the weather? Our human body is way more multifunctional than you could have imagined. Here's another short rhyme to prove we humans have superpowers. For instance, our body can predict rain. I know ladies by the score whose hair foretells the storm. Long before it begins to pour, their curls take a drooping form. See? I bet you've noticed it many times and maybe even correlated that our hair may act weirdly when the humidity rises. It may expand in length due to humid air, and naturally curly hair may droop. Naturally straight hair, vice versa, may even curl up a bit. If you have blonde hair, you're even more potent at rain forecasting, as it's more sensitive to humidity. On to more precise predictions. Yeah, it's cool to predict the weather, but what about predicting temperature? You can tell the temperature by counting a cricket's chirps. These guys are quite accurate thermometers. When it's warm, they chirp faster. When it's cold, their chirps get slower. Now, here's what you need to do to get the temperature. Count their chirps for 14 seconds, and then add 40 to the resulting number of chirps. Now comes the disclaimer. Crickets only work in Fahrenheit. For Celsius, you'll need to do some extra calculations. While not all weather lures are accurate all the time, they can be a fun way to predict the weather and connect with nature. Meanwhile, my hair is turning frizzy, so I'll grab an umbrella.
A heavy snowstorm rolls in, and then you hear it. A distinct sound of thunder and see lightning sparkling in the sky. Congrats! You're one of the rare people who has witnessed thunder snow. Until recently, scientists couldn't even agree that it's a real thing. But now, as they see more and more videos of it popping up online, they're trying to understand how it forms and how dangerous it really is. One thing is for sure, if you see lightning during a snowstorm, there's at least half a foot of snow falling somewhere nearby. We can even predict heavy snowfalls by thunder snow, but it doesn't work the other way around. Not every heavy snowfall causes thunder snow, and scientists are still wondering why. They think this beautiful natural event happens in a way that's kind of similar to summer storms. Turbulence in the air makes warm, moist air near the ground rise up into the sky. As it goes up, It cools down and forms clouds filled with tiny ice crystals, supercooled water, and soft hail called graupel. When these things crash around inside the cloud, they create an electrical charge, which leads to lightning and thunder. When it's cold enough for snow, the atmosphere doesn't have as much energy as it does in the summer. That's because the ground doesn't heat up as much in the winter, so there's less warmth and moisture in the air. So, there's less supercooled water in the clouds compared to a summer storm. When the right conditions do occur, it usually happens near the Great Lakes in the United States. In places like this, the cold air above mixes with the warm water from the lakes. This big difference in temperature creates areas where the air rises quickly, and those rising pockets can cause lightning and thunder during heavy lake effect snowstorms. They're also more common in the Colorado Front Range and Upper Great Plains. Another difference between thundersnow and a regular summer storm is that it's much harder to spot thundersnow. Snow absorbs sound waves, so you can only hear thunder if you're within a few miles of it. It will be more like a low rumble than a loud, sharp bang, and it's harder to see a flash of lightning against the backdrop of a bright white sky filled with flurries. This way, thundersnow can catch you off guard and strike just like any lightning. Although, lightning and thunder that come with a snowstorm are usually less frequent and less intense than those that come with summer storms. So, perhaps the worst thing that comes with thundersnow is those heavy snowfalls that can cause chaos on the roads and leave you without power for days. Another cool and rare winter weather phenomenon is the snow donut. You won't want to eat this donut as it looks like snowy wheels or tires. You can mostly find these rare natural snow shapes in the open prairies of North America or some remote places in Northern Europe. They need the perfect mix of conditions to form. First, there needs to be a layer of wet snow on the ground. The surface has to be something the wet snow can't stick to, like ice or very soft, powdery snow. Then, a strong but gentle wind or gravity on a hill has to push the snow just right. As the snow moves, it rolls up like a carpet and forms a big donut with a hole in the middle. Ever heard of the red lightning called sprites? Unlike regular lightning that strikes down from the clouds to the ground, they shoot up high into the atmosphere, about 50 miles above Earth. They're super fast, lasting just a tiny moment, so they're really hard to spot or study. Sprites happen because of a buildup of electricity in clouds, just like normal lightning. They're usually red and can look like jellyfish or carrots and get up to 30 miles wide. Pilots flying in high-altitude planes get the best views, and you can't see it from the ground. Scientists think sprites could happen on other planets with atmospheres. They tested this idea in a lab by recreating those planets' atmospheres and running electricity through them. It turned out they were right. A fall streak hole is a big circular or oval-shaped gap that sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. They need ice crystals to freeze. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once they're there, the water droplets freeze quickly, get bigger, and start to fall from the cloud. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. A mini tornado that spins up a lot of dust and dirt on a hot day is called a dust devil. They're little whirlwinds filled with dust and debris, and they can happen all over the world. They're smaller and not as strong as tornadoes, but they can still be powerful enough to knock over small objects or lift light things into the air. In really hot desert areas, they can grow much taller and last longer, sometimes for over an hour. Dust devils form on sunny days when the ground gets super hot. Once the dust devil is spinning fast enough, it acts like a chimney, with hot air rising up and cooler air sinking down through the middle. Dust devils can be dangerous if they're strong enough, so it's best to stay out of their way. Have you ever seen a fog bow? They form in a similar way to regular colorful rainbows, but they're much wider. Fog bows are made by tiny droplets in fog or clouds instead of big raindrops like in regular rainbows, but they also appear opposite the sun. You need to look for a fog bow in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean, where fog often forms. Because the water droplets in the fog are so tiny, fog bows don't have the regular bright rainbow colors. They might even look all white or faint. Some fog bows are hard to see at first because they blend into the mist, but once you spot them, they're easy to recognize. There are atmospheric rivers flowing high up in the sky. They're long, thin streams of air in the atmosphere that carry a lot of water vapor. Even though you can't see them, they sometimes hold as much water as the Mississippi River carries in one day. When these sky rivers reach land, the water vapor inside them often turns into rain or snow. Some are gentle and helpful, bringing much-needed water to dry areas. But the really big and powerful ones can cause heavy rainstorms or snowstorms. If they stop moving over certain areas, they can lead to flooding, mudslides, and other problems. One famous atmospheric river is called the Pineapple Express. It gets its name because it pulls warm, wet air all the way from tropical areas near Hawaii to places like the US West Coast. Mimetis clouds are some of the strangest and coolest ones in the sky, looking like big, fluffy pouches or bubbles. Their shape can change a lot. Some look like smooth bubbles and others stretch out like long tubes. Mimetis clouds usually form under big clouds. Inside these storm clouds, strong winds cause turbulence, which pushes air and moisture downward instead of upward like regular clouds. This creates those uneven, pouchy shapes. Because mimetis clouds are connected to powerful storm clouds, they're often a sign of bad weather, like heavy rain, hail, or lightning. In the winter, if it's cold enough, they can sometimes bring snow. Sometimes they appear with other, calmer clouds, but that's pretty rare. The best time to see mimetis clouds is when the sun is low in the sky, like at sunrise or sunset. The sunlight lights up the pouches, making them glow and look even more amazing. Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sinkhole within minutes.
Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.